Okay, so welcome everybody. So this is not quite the kickoff yet to the Earthscope training. The first one of our kickoff meetings is going to happen right after this one. So in about 55 minutes from now. Welcome to the this year's Earthscope ICE Plus INSAR course anyway. My name is Franz Meyer. I'm a professor at the University of Alaska Fairbanks, and I'm also the chief scientist of the Alaska Satellite Facility. I'm one of many instructors in this course, and maybe one of two coordinators of this course, one of three at least, along with Gareth and along with Melissa, who just disappeared. So maybe I throw it over to Gareth real quick.
Hi, everyone. I'm Gareth Funning. I'm a professor at the University of California, Riverside. What else to say? I've been doing InSAR for 25 years, which seems like a long time now I think about it. And I'm glad you're all here to learn how to do it because we need more InSAR people in the world. And Melissa,
yeah, that's it. Yeah, my PhD, just to give you a scale, I did my PhD, I think, on like 25 or so in the fairograms back in the day. So when data sets were really sparse back in the ERS days. So you're all blessed with Sentinel-1 and ISCE and all the other cool missions coming along. Melissa.
Hi, everyone. Hold on just a second. Let me put somebody in. Okay. Sorry. Melissa Weber, and I work for Earthscope. If you're familiar with what we used to be in the past was NAVCO and or IRIS. We merged in 2023, beginning of the year, and my particular job, I'm a community engagement coordinator, and I coordinate all the background logistics for virtual short courses and for events, live and in person, and other virtual events. And I manage all the Earthscope memberships.
I think we should hold off on introductions because we're going to do it all again in kickoff meetings.
I wanted to introduce one person though that's online today and may not be online every day, and that's Eric Lundell, who is on the call today. He's one of the people that's going to be helping you if you have issues getting access to OpenSAR Lab or other questions with OpenSAR Lab. So thanks, Eric, for dialing in.
Yeah, and also I noticed that Dylan's here too. He's the other guy who works at ASF will help too. So yeah.
Yeah. The point of this particular session is to get you familiarized with a computational platform that we're using for this course that's called OpenSAR Lab. We are using sort of a unified standardized platform for this training, partly because we have a large group of people in this course, about 150 people. Through Open Science Lab, OpenSAR Lab, we can give you all a standardized machine. So everybody gets the same installations, has all the software in it. So if there is an issue with code, which may happen throughout the week, at least everybody will have the same problem. So debugging these issues is going to be much more straightforward for this particular course. We will, at the very end, give you some instructions how you can install all of these things locally. But I would encourage you all, or almost insist on using Open Science Lab for this particular training, so that we can focus on actually conveying the information instead of having to work with you on debugging your installations. So stick to OpenSAR Lab, Open Science Lab for this week and next week, but we'll give you whatever you need to also replicate and install all the necessary code locally. And so as we go through this, feel free to ask questions, either put them in chat or just speak up as I'm quickly going through some slides. So I'm just going to show you a few slides, and then we're going to hop on the environment. In fact, as we go through the slides, there is a link to Open Science Lab in the slide deck, and I encourage you to click that and get your instance started as we go through. So short introduction to Open Science Lab. You see there's a link to the platform at opensciencelab.asf.alaska.edu. It is a fully pre-installed and fully cloud-based processing environment. We are using an instantiation of Open Science Lab that is specific for SAR. So it comes with all the open source installations that you may need. So we'll particularly work with things like ICE, particularly ISCE2 in this training. We'll be switching to ISCE3 soon. Now that ISAR is launched, we will be offering a training at the very least next year in the summer that focuses more on ISCE3 type workflows. We also demonstrate InSAR time series analysis workflows such as MinPy, using software packages such as MinPy. You will learn about things like Opera, which is also open source code, and other modeling codes that are open source available. So all these codes are installed and ready for you to use. You'll see that the Open Science Lab runs in a browser, so you can access it from every internet-enabled device as long as you have a web browser on it and as long as you have enough internet to visualize a website. The service overall sits in Amazon Web Services right next to ASF's data holdings. So that's convenient because it allows you very quick and easy access to all of the SAR data holdings that are available at ASF, and actually also easy access to additional SAR data sets that you might want to retrieve from the UNAFGO or the EarthScope data holdings, because also EarthScope is sitting in Amazon in the same region in AWS West 2. So if you go to the page, I'm going to click on that link here real quick, and I think I may have to reshare. So I'm going to stop sharing and make sure that you actually see what I'm doing. So you should all see a website like this. Actually, you may see a login screen. Let me go to my incognito browser real quick. So you may see a screen that looks somewhat like this. We pull up chat and see if you can confirm. With a thumbs up, once you click on that link, you should get to a website similar to this. I see there's a thumbs up, there's some. So all of you should be able to get to that point. So at this point, you can log into the service. To log in, you need a username and password. I think most of you should have already signed up for a username and password. If you haven't done that yet, please click on this little link down here that says sign up. If you click on that, you get to a little form. On that form, we ask you a few questions. You need to define a username. You need to give us a valid email address. It's very important that whatever email address you use here is an actual valid email address that you also check, because before you get access, we will send you an email to that email address for sort of two-factor authentication and to activate your account. So please use an email address here that actually works. Then you can set up a password and then click on the registration link, and that will then be reviewed by the team, and you should get access in a short order. So if you haven't yet signed up, please use this chance to create a username and sign up for this course. Once you have username,
can I interrupt really quickly?
Go ahead.
Sorry, I was just going to say, we don't actually review these signups. You'll receive an email in your inbox once you hit the sign up button. There's going to be a link in that email, and once you click that, your account will be verified. So it's all on you. You don't have to wait for us to do anything there.
Excellent. So one thing I also want to mention is to register or to sign into the platform. You need to set up a multi-factor authentication method. So there's a variety of different solutions out there that you can use. I use an app called Duo for this purpose, but there's also a Google Authenticator, and I don't know, OpenSAR Lab team, if you know of other ones, that are useful for this kind of stuff. And
Use
so
Google
that
Authenticator. Sorry, go ahead.
Yeah, and so this gives you like a code that you can type in, which I'm now showing to the world as I'm typing it in to my computer. And then hopefully this works and you can sign into the platform. So for the ones that have an account already, please try to log into the platform and let me know if you end up at a page that looks like this. I see some thumbs up. Excellent. So this is sort of our, what do we call this, our portal where you come in. That shows you all of the sort of Open Science Lab deployments that you have access to. So we operate a number of different deployments for different communities, and you may have access to all of them or subsets of them or one of them only. So in my case, you see that I have access to two deployments. One of them is called OpenSAR Lab. This is the deployment that the ASF data center is making available to its user community. It's another one that is specifically designed for usage with SAR. And so that one I have access to. And then when I scroll down, I also have access to this second one, which is the 2025 EarthScope InSAR workshop deployment. And so all of you should have access to this deployment. Maybe I see Dylan is answering some questions in chat.
I think the key is that you will get access to this, but if you don't have access to it straight away, you should post your username on the Slack channel where Dylan and Eric have been reviewing people's requests to get access and have been granting them access.
Yes, so if you don't currently see this deployment, please go to the Slack channel into the ICE short course Slack channel and post a question with issues you may have similar to this, where you tag both Eric Lundell and Dylan to ensure that you're added to the platform. So if you have issues, please utilize Slack. Instead of putting it in chat here, because in Slack we can actually track responses, you can have follow-up questions, and we can make sure that we close all of the access issues. Okay, so once you're there, you can then start your instance. And so we are going to use the EarthScope InSAR workshop instance, as you would probably imagine. And there's a little button that you can click that's called Go to Lab. When you click that, I have my server running already, so I'm going to stop my server real quick. So to show you what you should see, you see two different server options. So you can start two different machines of different size. It shows you here what these machines look like, what their sort of RAM availability is, and CPU availability and storage availability. Today, it is fine to use the M6A large for the things that we are doing. But you also have a larger one available for the larger exercises, like an M6A X large. So I'm going to just start the M6A large. Whenever you can, it's good to use the smaller machine. We'll try to make sure that you know for the next day what kind of server you might need. These servers all come with costs. So if we always run the largest instance, we'll create more costs than we actually need. So if you can be mindful of your server size, that helps us all out. There's a start button that you can click. What happens now is that in the back end, a machine is being created, a virtual machine with a certain setup. All of the software code is being installed. Then additionally, at every startup, we are fetching all the necessary content, like the notebook content and the exercise content for this course from GitHub, and basically deposit and install it here on this machine. So the fetch from GitHub happens at every restart. And so we may actually ask you to restart your server sometime this week or next week. As we update notebooks, we may find a last-minute problem in a notebook and update that notebook. We may ask you to restart your server. What happens then is during restart, the latest code content is being fetched from GitHub. And this way you're ensured to have the latest versions of the code available. Depending on when you last started your machine, this may take a few minutes to spin up. And in the meantime, you can give me thumbs up for folks that made it that far and maybe have already machine up.
And this bit always takes ages.
Well, ages is
ages. Like geological periods long.
Oh, yeah, the server image is about 8 gigabytes in size, so it does take a while. The fact that it's saying stopping container notebook is not a good sign, unfortunately. It should be saying starting container notebook. So,
oh, you think that my instance is?
I don't know, but this is a good time to let everyone know that if something does not start, let us know. Because once again, if it's not starting, then something is broken and it's affecting other people. So the faster we know about, the faster we can fix it, the faster everyone else can get on their way. Can you open the event log again?
Can?
Yeah, and then scroll down.
You see the last one?
Yeah, it says starting container notebook and it says stopping container. I just find that odd. This is what happens when you do live presentation demos. Things always go wrong.
Oh, I did a training earlier today of some code that we've developed and it broke. Because overnight somebody updated a Python library and changed the way how you fetch data. But how are you all guys doing? Does anybody have, give us a thumbs up if somebody was able to start the machine all the way? I see people are up and running. And I actually haven't run the smaller machine in a while, so that might be the problem. Should I start the bigger one? Let me see here. I just stop my server and what? Fine. Does anybody, Gareth, did you start your machine also?
Mine was already running.
You want to take over real quick so that I don't delay this?
Oh, but not on this machine, on my other computer.
Oh, I see. Eric or Dylan, do you have a deployment, a machine on that deployment up?
Yeah, I'm starting a server right now and see if it works. And since we're waiting, I just let everyone else know that usually if it's a cold server, it will take about 6 minutes to start a server. It's not instance because, like I said, it's like you're downloading 8 gigabyte images and you're doing initializations and all that stuff. If, however, you have a warm server, because like someone just got off and the thing hasn't shut down yet, the machine itself, then you can probably pop on in 30 seconds. So it really depends. But in this case, if it says pulling image like this, then you're pulling a brand new image. It's start a brand new cold machine. It's going to take probably 6 to 8 minutes, depending, to actually start. So don't worry if it takes forever. If it does time out after 10 minutes, then let us know via Slack that, hey, this happened, and we can investigate.
Okay. So, Eric, do you have a machine up, or Dylan?
I do not.
I see questions in chat. Oh yeah, so somebody's up, I see.
Hang on. I will try and get myself open on here.
Okay, I got one wording, but since you're pulling an image, we should, in a few more minutes, you should be up and running there, Franz.
Yeah, and I see somebody put a image in chat. So this is what you would expect. I see excited thumbs up for people that are in. And I totally admit this was my mistake. I was on the larger machine, which was already warmed up, but should have picked that one. But no.
Go big
Oh,
or
here we
go
go.
home.
Yay, I'm in. Okay, so once you're in, you see the Jupyter Lab setup. Maybe let me ask real quick in the round, who has never worked with Jupyter notebooks? Usually the number of people that haven't seen notebooks is shrinking over time, but there may still be people out there that haven't done much work with notebooks. So it's a judgment-free zone. So just to give us some information, like who has never used notebooks before? It seems like I don't get any thumbs up. So maybe you're all familiar. So, it's a Jupyter Lab setup. It looks somewhat similar from, what you might be familiar with from like your R installation or MATLAB or something similar. You have a launcher window in the middle where you can, open up different kinds of, things you want to work on. You can create a notebook up here by clicking on one of those buttons. It would create a new instance of a notebook. You see I have three options. In my case, I have three different existing pre-installed kernels already. So I could click on one of those and it would automatically launch a notebook that uses this particular kernel. So here's the Erscope one. If I click that, if I would do that, it would launch a brand new notebook that would have available to it all of the software tools and Python packages that are part of the Erscope InSAR kernel. So the Erscope InSAR kernel is the one that we'll be using for most of this class and for most of the exercises throughout next week. I'm going to discard this one. You can also, other things that you might want to do as you go through the class is you could also open like a terminal window and do, command line stuff. You could run Python code here. You could also, delete or create folders. You may, download lots of data that you want to delete at some point. So you can do all of this stuff on through your terminal window. So this is sort of the main space here, which will show you the notebooks that you're working on or the terminals you have open, or give you this launcher window where you can start and create new content. On the left-hand side is your folder structure. So it shows you what's all contained on your machine. If you are in the home folder like this, you see that you should see three folders in your case. You should see one that's called 2025 ISCE Plus. This is the folder that contains all of your content that we use for this particular class. So all of the notebooks and workflows and PDFs for this course are contained in this particular folder. The other folder is called Conda Environments. This can be a useful one because you may want to potentially build other kernels, or we may ask you at some point to rebuild the Erscope InSAR kernel if we discover an issue. And so a lot of people are not super familiar with building Conda environments, so sort of kernels. So the OpenSAR Lab team put together a really handy notebook that you can just run through to build a new kernel. So this is a good example, a first example of a notebook. These Jupyter notebooks that we'll be using, they are basically a sequence of either code cells or markdown cells or mixtures of those two. This first cell that you can see here, that's sort of marked by this the blue bar on the side, this is so-called markdown cells. A markdown cell is one that contains instructions in a form of text. You can also add HTML code to markdown cells. You can use LaTeX to render equations, and you can add graphics to these cells. So those are mostly used for instructional or explanatory content around the code that you're running in a particular notebook. This next cell here is a so-called code cell. So this is, in this case, exposed Python code. In theory, these Jupyter hubs can support a whole range of different coding languages, including also Octave and Python, C, etc. All of the notebooks that we're using in this course are Python notebooks. So all the language, the programming, and the code that you'll be using is in Python. The way you work with notebooks is that you read through them. They basically are, you could compare them to like a data recipe, which explains to you how to process certain data sets. But in contrast to like a PDF data recipe, it actually includes the executable code. What's important when you run through a notebook is that you run the code cells in the order they are given, and you don't leave any code cells out. So you have to run them all, and you have to run them in the order as they are given, because you may declare a variable in one code cell that you want to reuse in another one. And if you didn't run the first code cell, your code will break. So typically the way they look is the first code cell is always one that imports a bunch of Python libraries that you might want to use for this particular notebook. To run this code cell, there's two options. One of them is if you move your mouse upward and you sort of look at your screen, there is a little sideways triangle, just like a play button. If you click that, it's going to run this particular code cell. While it's running, you see that between those two square brackets, there is a little star or an asterisk. Once the code cell is completed, it's replaced by a number. And this number is a sequential number that numbers all the code cells that you've run in order. So if I go to the next code cell down here and I run this one, it's going to show a little 2 on the side. And so the highest number in the notebook is always the code cell that you ran last. And so I just showed also, what I did just now is I ran this code cell in a different way. What you can also do is you can click into that code cell, and on your keyboard, you can hold down the Shift key and then the Enter key, and it's going to run the code cell and jump to the next cell. This is a handy thing if you want to run through a notebook really quickly and you don't want to have to move your mouse up and down all the time to click that play button. So I hardly ever use this button. I usually just use the keyboard to progress through a notebook. So this is how you interact with notebooks. And so this particular notebook would let you build or rebuild Conda environments or kernels, software environments that you will need to exercise certain notebooks. So it's a really handy thing to have. There's a number of different Conda environments that you can build. If you want to know which ones are available, there's some subfolders here, like one that's called the environment config. If you click on there, you see a bunch of files that end in YML. These are YAML files. These are essentially text files that tell the kernel which kinds of software packages need to be installed using which kind of process. So here's some Conda installs and there's some pip installs that are in this particular one. So this is the Earthscope InSAR kernel, for instance. These are all the libraries that are being installed. Okay. Going back to the main folder, the other one is a lost and found. I actually don't know what we use that for, but it's there. I have an additional folder here that's called temp. So this is my own content where I was, doing some debugging code cells. So you don't have that folder. Then if you go to the 2025 ISE Plus folder, this then contains the content that you need for this course. You see that there's separate folders for the different units that we'll go through. And these folders are labeled like 0.1, 0.2, and so on. The folders that start with 0, these are the pre-course exercises that we want you to go through. In the next session, when we give you an introduction to the course overall, we'll show you the syllabus for this course, where all of these pre-course assessments also and pre-course activities are also listed. So we'll talk about those a little bit more in the next hour. Then accordingly, 1.0, that's the first day of the course, and it goes all the way to 5. You see that we don't have day 5 content in there quite yet. So this list is going to grow throughout the week as we add content and update content throughout. If you want, you can look into some of these folders. For instance, you can go into 1.2. That's a good one because it has a variety of different content in it. So 1.2 has here 3 files that you can see, and these files are of different nature. There's a PowerPoint file for some slides that will be shown on day 1, PDF version of the slide deck. But then more importantly, there's this one file that ends with IPYNB. This is one of those notebook files. So on the machine, you can identify a notebook file in 2 ways. It's the extension IPYNB, and then in the front of it, you see this little bookmark type symbol. This is another way of how you can identify those. So this is one of the notebooks that will be running this week. And I'm going to show this to you a little bit because I showed you earlier that in these markdown cells, there's a variety of different things you can do. You can include graphics, as you see here. You can format your text using either HTML or Markdown command structure. You can create, color background to highlight things. So there's a variety of things that you can do to streamline the way the content of a notebook is presented. Equally so, if you scroll down a little bit further, there is ways of including equations. Somewhere in here I have equations. So this is some LaTeX code. If I double click this, you see sort of in the background, if you're familiar with LaTeX, so all of your standard LaTeX is compatible with notebooks in those markdown cells. If you by accident double-clicked one of those markdown cells and you see sort of the background, either HTML or LaTeX code, you can just re-render this code cell the same way by either doing Shift-Enter or instead clicking this little play button up here. So we'll go through these notebooks throughout the week. Some of these notebooks will have assignments. So this particular notebook highlights that with the sort of blue boxes. And it tells you here that this notebook does include 3 homework assignments. And in this particular case, the questions in that notebook, they are to be answered on the Moodle platform, which is the learning management system that we use in this course. And we'll show you in a little bit more detail in the next hour. Let's see, what else to explain? There's a couple of additional things worth knowing. When you are coming, there's lots of chat questions. Do we have any open chat questions? Are you guys following?
Working on it, don't worry.
Okay. As we come to the end of the day, it would be courteous of you if you, before you leave and go do other things, if you were to shut down your computer, your instance in the cloud. To do that, there's a handy button on the top right. Hopefully you see this. There's a button that says shut down and log out page. If you click on that, it gives you an option to stop your server. And again, there's not a huge, I mean, we actually will automatically shut down your machine after a certain time. Eric and Dylan, do you know how long that is? Once the machine is idling?
If it's purely idling, it'll shut down in about 20 minutes. However, if Jupyter Hub thinks that there's some process, the background's going on, it might not shut down. And that's why we prefer that you do it manually when you at the end of the day, so that we don't have this thing running for 24 hours.
Yeah, so if you think of it, go to this and stop your server before you leave. Another reason why you might want to do this at times is, for instance, what may happen. Let me go back to my, how do I get back to my, oh, I should have clicked on my server. For instance, what may happen is you may have worked on a notebook and you may have totally screwed this up. So let's say, I added gobbledygook to my code cell and I ran it and I get horrible errors and I just can't figure out, how to fix this notebook. So one thing that you can do if you broke your notebook for some reason, you can simply close the notebook. Oh, this is the Conda environment one, so I shouldn't probably close that notebook. Kind of fix this. Let me open the other one. So let's say I screw this one up. Horrible stuff. It breaks. I have an error. Everything's horrible. I don't know what to do. So one thing you can do is you can just close the notebook. You can then delete the notebook. So you can go over here and just remove the notebook entirely from the instance. And then you can go through this process where you stop your server. So now I'm shutting down my machine. And then once it's shut down, I'm going to restart my server. And what happens now is the machine restarts. This should go much faster now because it shouldn't have to pull in the machine image. We'll see. And once the machine is back up, in the launching process, it's fetching all the notebook content again from GitHub. It's going to recognize that this one notebook is missing because I deleted it. And it's going to refetch that notebook and populate it back on the machine. So I will be ending up with a pristine, untouched notebook, an unbroken notebook that I can then, start with from scratch. So now as it launches again, you can see that this notebook now is back, and it just pulled it back in a few seconds ago. And so this is one way if you really completely, screwed something up or you completely lost with a notebook and want to start from scratch. That's one reason why you might want to restart the machine. The other reason is we may have updated some code and we may ask you to restart your machine. One more thing I want to show is if you are still fairly new to the sort of notebook environments in Jupyter Hub environment, there is a handy link up here that's called OpenSAR Lab Docs. If you click on that, you get to a website. Uh-oh.
Yeah, we need to update that. We updated the link. So we could get rid of the user guides part. Just
okay. Yeah. So now you know how to unbreak that. So this gives you a bunch of instructions, information on what is OpenSAR Lab, how does it work, and then how to access OpenSAR Lab and so on. So there's some help information available on this website. Do we still have information on like how to build Conda environments? Is that moved some other place now?
Yeah, if you pop up those 3 lines at the top left, you'll see all the subsections.
Oh,
sorry, the top left of the window.
Oh, I see.
Yeah, there's all kinds of stuff in there.
So lots of content about Jupyter Hub and Jupyter contents and kernels and all that kind of stuff. So feel free to peruse. Hopefully you find that useful if you run into trouble, if you want to know more about notebooks. Let's see. Anything else we need to point out?
I would like to point two other things out. First is every person has their own individual persistent storage. So as in everything in your home directory, everything on your server is persisted. So don't worry about like, if I stop my server, I lose stuff. You shouldn't. And since this course is really short, chances are you won't even see the email saying, your storage is going to be deleted after a few weeks. So yeah, use this as like it's your own personal computer in that sense. You can store stuff for the class and be fine. The second thing is up the very top there, you have a thing called GIF capture. That is a link to another site. You can click on it. And it basically will allow you to be able to create a GIF screen capture, a screen recording of a GIF. And you can click that, and then you can select, it lets you select which tab you want to open. And the beautiful thing about this is that you can start recording, and it will record what you're doing, and then it will save it as a GIF, and then you can share that. So if you run into a problem you can't figure out, then your one option is to create a screen capture what you have, and then share that, and then we can visually see what the problem is. The other option is just to say, hey, can you jump onto my server? All the OSL admins, me and Dylan, have access to everyone's servers if we need to. So with permission, we can go ahead and jump onto your servers and we can play with it ourselves. Even though,
how do I stop the recording?
Go back to that tab that you
Oh.
started, the second tab there. Yeah,
I can't see it. Here we go.
yeah, that and the stop recording.
Okay.
And then basically, if you notice, it kind of plays back. There's like a little timeline at the bottom there where you can, if you move the red thingies, you can shorten the capture. But yeah, so the idea is then you can render it, and then you'll download a GIF of your thing, which is fairly small. It's only maybe a couple megs in size. But I'm just saying is that we put that up there so that if people have issues and they want to share what their problem is visually, it's a little easier to do that. If you don't want to do that, you can always use your computer's screen capturing. But I've found that just be easier to use sometimes. Oh, another thing here is up top, there's a disk space used. Like right now, Franz is using 1.83% of his storage space, and every person has about 100 gigabytes of storage. Look at that as it approaches 80% usage, it will turn yellow. And then if it hits 9% usage, it'll turn red. And if it's above 95% usage, it'll start flashing red, very noticeably. If you use 100% of your storage, you might be able to lock yourself out of your account. And we have to play with it to get back in. So
yeah, the reason is if you shut down and restart your machine, Linux needs a little bit of extra space during the booting process, and if there's no space left, it can't start. And so then the team has to help you out. But you can also use, I assume not many of you will run into that problem, but if you have that problem, you can Slack and tag Eric and Dylan, and we'll figure out how to help you.
right. So yeah.
Excellent. Are there any other questions about the platform or the code that we're using? Oh, maybe I should show real quick one more thing. Let's see where my tab is that I was trying to show. All the content of this course is exposed on GitHub. There's a link in the syllabus that will maybe run through also later. But we have a GitHub organization that's called ISCE+. So that contains all the content for this course. And in that organization, we have currently a couple of repositories. We have this year's course content, which is in this repository 2025 ISCE+. And then we have last year's repository, over here, or maybe all the previous year's repositories. No, it's just last year available for you. And so as we go through the following years, they're going to be more repositories over time. But you can, after the course is over, you can feel free to clone this repo to your local machine to have the content, the notebooks, and all the exercises available locally. That's, I think, all I wanted to talk about today. But let's see if anybody has any questions. And if that is not the case, then
there was a question, Franz, about which what environment people are supposed to use.
Yeah, so we'll be using the Earthscope InSAR environment. We're still tinkering with that environment a little bit, so we may ask you next week to restart the server. It may also be that for an exercise or two, we might build a separate environment together, which might not be a bad idea anyway, to get you familiarized with the process of building a Conda environment as part of this course. But predominantly, we'll be using the Earthscope InSAR kernel, which is actually pre-built on your machine, so you don't necessarily have to build that unless we update it or we find an issue. Then we may ask you to build it sometime next week as we go through the course.
The Dolphin class on Friday will have to be a separate kernel because that uses ISCE 3.
Yep. And that's also a good experience if in the future you'll be doing your own software projects. It sometimes is useful to have different kernels for different things rather than having a very large kernel. There's interdependencies of Python packages that can really get you if you have too large of too many libraries that you're trying to combine. Okay, great. Then looking forward to the kickoff. Hopefully you'll be available for either the kickoff here in 10 minutes or the kickoff tomorrow. If you dial in for the kickoff in 10 minutes, then you have 10 minutes worth of time to fetch a coffee or walk around and refresh yourself. And we see you in about 10.